Thanks, everyone. We will make a start. Okay, so part of what we do today, we'll go over some of the solving simultaneous equations by elimination that you would have done with the relief teacher yesterday. From my little conversations with you around the room, your understanding so far, would be fair to say, is mixed. So what we're going to do, I'll explain these practical problems using solving simultaneous equations using elimination, so what you were doing yesterday to help you get back up to speed. If you've just joined us after coming back from break, welcome back. Just a quick note on solving using simultaneous equations. What we're looking for with this, if you've got the graphs of two linear equations, they'll cross over at some point. So at that point, the equations for both lines make sense. And they'll have a coordinate of x is equal to something, and y is equal to something. When we solve simultaneous equations, that's what we're looking for. We're looking for that intersection between the two. So that's the purpose of what we do when we do this particular job. What we're doing today, we're given a couple of worded problems. So I'm going to show you how to label it properly, how to work through it, how to make it really clear what you're actually doing and solve via elimination. Okay. So the first question reads, the sum of the ages of two children is 17, and the difference in their ages is 5. And if Cara is the older sister of Ben, determine their ages. Okay, you've been given a worded problem. There's no variables in there. We need to come up with those on our own, but we need to make it clear. Boys listening, please. We need to make it clear what we're using for our variables and where they come from. So I'm going to say, as my first bit of working out, I'm going to define what those variables are. I'm going to say K is going to be Cara, and predictably B is going to be Ben. All right, and B be Ben. Like K be Cara and B be Ben. B be Ben. That sounds really funny. Okay. Yeah, something like that. Oh, he's no longer with us. Not in like, you know, not on this planet, just not in this classroom. Yeah. Okay. So that's job number one, to define the variables. Job number two is to use the information in the question to come up with some equations. So if the sum of the ages is 17, we know that K plus B, so Cara's age and Ben's age, added those together, that would give us 17. I'm going to say that's equation 1 for us. Equation 2, the difference in the ages is 5, and Cara is older as well. So if we started off with Cara's age and took away Ben's age, the difference between the two is 5. So they're the two equations that we need. Now, this one has been a little bit kind to us, because for our first equation, we've got a value for B of +1, so plus 1b. Second one, we've got -1b. So what I'm going to do for this one, we can just as easily, well, we can easily add those two together. So I'm going to say what I'm doing. I'm going to say equation 1 plus equation 2 will give me, well, k plus k is 2k. B take away b is nothing. 17 plus 5 is 22. So that's what we mean by solving simultaneous equations using elimination. We're trying to eliminate one of the variables that's given, trying to get rid of it. So now we've got 2 lots of k is equal to 22. I can now solve that, divide both sides by 2, gives me k is equal to 11. Now for my next step, and again, I'm going to let the reader or the marker or whoever it is know what I'm actually doing. I'm going to say substitute k equals 11 into, let's say, into equation 1. So equation 1 is Cara's age plus Ben's age is 11. No, it's not, 17. We've just figured out what Kara's age is. It's that's 11. So 11 plus Ben's age will give us 17. That tells us that B is equal to 6. And with these questions, worded question means worded answer, so make sure you're writing a statement as well. I'm going to say, therefore, Kara is 11. Good for her. Ben is 6. Good for him. Ben does not know the harsh realities of life yet. Okay, so just to recap that quickly, that was a pretty easy combination to get us started, but when we solve problems using simultaneous equations, in this case via elimination, we're looking to add or subtract bits of the equation to eliminate one of the variables. Where that gets a little bit harder is for a question like the next one. Am I good to rub this away? Yeah. Give me a big nod if I can rub it away. Yes. Thanks, JW. If you're wondering why I've just given you a nickname, I'm conscious of using people's real names in the video when I put it on YouTube later. So, yep. No, because with the follow, it always put me in the middle when really I want the whole board. So that's what I wanted this time. Okay, this one is a little different. So we've got a nice man named John is buying some flowers for his mother or his partner or whatever. He's bought 3 daffodils and 5 petunias for $25. We've got 4 and then Julia buys 4 daffodils and 3 petunias for $26. Okay. What's job number 1 from the previous question? What do I do before I do anything else? Maxi? Yes, legend, perfect. So I'm going to define my variables for that one. So I'm going to let D be daffodils. 2 F's in daffodils. Daffodils. And with a growing sense of inevitability, P, B, petunias. Petunias is a strange word, isn't it?
Yes.
Yeah.
Quite strange.
It's quite strange, I agree. Okay, now we write our expression down for each of those, and again, this comes from the information in the question. So we'll say equation 1, 3 daffodils, so 3 lots of D, 3D, and 5 petunias is equal to $25. So that's our first equation, 3D plus 5P is equal to 25. Next equation, 4 lots of daffodils plus 3 lots of petunias is equal to $26. Maybe Julia wanted to spend more money or likes petunias less. Who knows? And we'll call that equation number 2. Okay, where this question's a little bit different, so for question 1 where we had K plus B and then K minus B, we could combine those 2 equations together without doing any other work to make them fit together. This one though is a little different. So if we say took equation 1 from equation 2, we'd have 1 lot of D and negative 2 lots of P, which doesn't eliminate the variables. They're still there. We want to eliminate them. Eliminate them. So what I'm going to do instead is think about how I can multiply or divide each of the equations to give me a common value for one of the variables. So what I'm going to do for this one, I'm going to look at it and say, well, if I multiply equation 1, if I multiply equation 1 by 4, I'll get 12D as a value here. If I do a similar thing for equation 2, if I multiply that by 3, I'd get 12D as well, and then I'd be able to combine them. So what I'm going to do now, I'm going to say equation 1 times, what did I say, times 4. That would give me 12D plus 20P is equal to 100. So I've not changed anything about the equation because I've multiplied everything by the same amount. It's still got the same relationship. It's still in proportion. I'm going to give this a new name now. I'm going to call that equation 3. Cool. Now I'm going to do the same thing to equation 2. So 2 times 3. And this will be equation 4 for me. So 4 times 3 is also 12d. 3 times 3 is 9, so 9p. And 3 times 26 is 78. Okay, so now by manipulating it, did I pronounce that right? By manipulating it, I've got 2 equations that have the same proportion as 1 and 2, but I can combine these to eliminate one of the variables. So what I'm going to do now, I'm going to say equation 3, take away equation 4. So 12 take away 12d take 12d is nothing. That's eliminated. Eliminated. 20p take away 9p is 11p. And 100 take away 78 is 22. I've nearly run out of room, but that's fine. Yes, awesome. So p is 2. Very good. So I've divided both of those by 11. Okay, now remember when we solve simultaneous equations, we're looking for the intersect of those two lines. We've got the value for p, now we need the value for d. So same thing again, I want to make it really, really clear what my next step is. So I've said, I've done all my labeling here, so that's all up to date. What I'm going to do now is substitute p equals 2 into basically whichever equation you want. I'm going to go into equation number 1. So that's 3d plus 5p is equal to 25. So I'll substitute in p equals 2. So now 3d plus 5 times 2, which is 10, is 25. That means 3 lots of d is 15. Take 10 from both sides. To get the value for daffodils, divide both sides by 3. So d is going to be equal to 5. Again, okay, how do we finish this? It's a worded question, so we need to have a worded answer. Very good. So we need to write a statement to finish it off. Therefore, daffodils are 5 buckos. Petunias. Every time I see petunias, I think of Harry Potter. Does anyone else have the same thing? I'm 32 years old, and last year I finished reading Harry Potter for the first time. Never read it, but last year I finished all the way to the end. I don't know if you know, but they're quite good books. If you haven't read them, you could try reading them. Apparently they're quite popular. Some of you may have read them already. Okay, so do like a quick checklist now in your mind to make sure that you've covered all the bases. I've defined my variables. I've said what d and p are equal to. All the way along, I've made it really clear what I'm doing with my equations. I've labeled these equations. I've let the reader or the marker know what I've done to them, including taking them away. I've let the reader or marker know that I've substituted the value in to give me the answer that I'm looking for. Cool. I'm going to leave those up on the board in case you need to scribble them down. Feel free to take a picture or whatever if you need. Does that address a lot of your queries from yesterday, kind of? Kind of? I'll come around and help you individually with that. Today you're doing Essential Maths 10.